Hello and welcome to another video. In this video we are going to be looking at how we can calculate the area underneath the standard normal distribution for a given region for given z-scores, using GeoGebra and the probability calculator within GeoGebra. So within GeoGebra, if you are using the app-based GeoGebra software, so if you're on an iPod or an iPad, I meant to say an iPad, or an iPhone or an Android phone, make sure that you download the GeoGebra Calculator Suite from the App Store. If you are using the web-based GeoGebra, we can choose the different type of calculator either way, whether it's app-based or web-based. We can choose whichever calculator we want to by pressing the three lines in the top, which is called the hamburger, and pressing Switch Calculator. From here, we're going to choose the probability calculator, and we will now have our probability calculator. So we're going to use this for all of these examples today. There's another video that describes the relationship between the area under the curve, area under the standard normal curve, is equal to the probability that our value, that a random value, is in that region, or in this region. So we are trying to find the area to the left of a z-score of negative 0.53. What is the probability that a randomly selected z-score or a randomly selected data value will be in this region? So again, in the probability calculator in GeoGebra, just in case you missed it before, press the hamburger, press Switch Calculator, and then choose the probability calculator. In this calculator, we can change the different type of distributions. We're going to leave it as normal. We're not going to change the cumulative. We don't need to worry about any of that stuff. But from here, we're going to just choose either it's left shaded, central shaded, or between, or right shaded. We could also do the outside or the tails, but for the examples I have in today's video, we're not going to have any of these examples. So we're going to choose the correct shading based off the picture. So the graph on the left is giving us a z-score of negative 0.53. We want to know what's the area to the left of it, or what is the probability that our given value or a randomly selected value is to the left of it. Since we're talking about the standard normal distribution, the standard normal distribution has a z-score of 0 and a standard deviation of 1. We get this because we are using z-scores. We are standardizing all these values. And if I were to estimate this really quickly, I would estimate this z-score. Sorry. I didn't mean to do that. I was thinking of something else and I misspoke. Never mind. Let's ignore that I said any of that. Our x value will be negative 0.53. If we type in negative 0.53 here, we will get the area, or the probability, right here, of 0.2981. All right, so that's how we are going to use GeoGebra to find the area underneath the curve for the given region. There are some other videos that show a little different way of doing this, but they're based on different types of calculators, so we don't need to worry about any of the other stuff that we need to in the other videos. GeoGebra is quite nice for doing these. To find the area to the right of a z-score of 1.25, in this shaded region here, we're just going to choose the right tail shading. Again, the standard normal distribution has a mean of 0 and a standard deviation of 1. We're going to type in an x value of 1.25. And we will get that the area to the right is 0.1056. Again, just relating this back to the area, this is the same thing as the probability of selecting a random variable that is greater than 1.25 standard deviations away from the mean. We have three more quick examples. Each of these three examples show the same area. It says find the proportion of the area under the curve for the following z-scores, and they're all three to the left of the given z-score. So for the first one, we're going to, oops, that's not where I meant to put that. That's closer to negative 1.85. We want to shade to the left of negative 0.185. We want to find the area or the proportion or the probability that our z-score is less than negative 1.85. So to find this probability, we're going to choose a left shaded region, and we're just going to type in our z-score of negative 1.85. What you'll notice is nice about GeoGebra is I can just double click in any of these entries and change it very easily. So the p-value here will be 0.0322. Just a quick note here, whenever you're dealing with the areas, area should be rounded to 4 place values unless you're told otherwise. Oops, 4 place values, 4 decimal places, unless you're told otherwise. So for the second graph, we will have a z-score of 1.5, somewhere over here, shading to the left, z-score of 1.5. What you'll notice about the first picture for part A is that the area to the left is quite small. It's a very small region of the graph, and that's why the proportion is 0.0322, or approximately 3% of the graph. For graph B, you'll notice that it's a much larger portion of the graph. And we'll see that with our answer here. If we put 1.5, again, we're still shading to the left, so we don't need to change that. We'll see that our area is 0.9332. So a much, much larger portion of the graph. And then the third picture here, the third example, says, what's the area to the left of a z-score of 0? Well, since this graph is symmetric, we know that half of the area should be to the left of the graph. So this should be a probability value of 0.5. Let's just double check it here. 0 rather, gives us a probability of 0.5. So that's how we can calculate the area under the curve to the left of given z-scores using GeoGebra. We can also look at a few examples of calculating the area under the curve to the right of the following z-scores. Since GeoGebra is really nicely selectable between left and right, we can just select right for all of these and type in the given z-scores. In this case, to the right of negative 1.37. We can just type in here a z-score of negative 1.37. Gives us an area of 0.9147. If we look at the second picture here, to the right of a z-score of 0. Well, we did this earlier. To the right of a z-score of 0, the probability should be 0.5. I'll be a little bit more precise here. The probability that our x value is greater than 0 is going to be 0.5, half the graph. And our third picture here has a z-score of 0.67. We want to know what's the probability that our z-score is above 0.67. What you'll notice about each of these pictures is that for the first picture, part A, more than half the graph is shaded, so our probability is more than 0.5. For the second picture, part B, half the graph is shaded, so our probability is 0.5. And in part C, less than half of the graph is shaded, so our probability that the z-score is greater than 0.67 should be less than half. So let's type in 0.67 here. And we'll get that the area is 0.2514. Not too bad so far. We have a few more examples here. This one is asking us to find the proportion of the area under the curve between z of 0 and z equals 1.5? Well, again, with GeoGebra, it's pretty straightforward. In this case, we will choose the between option in the probability calculator. Since we're talking about the standard normal curve, we're talking about the standard normal distribution, our mean is going to be 0 and our standard deviation is going to remain 1. Now we're just going to type in that the lower value is 0 and the upper value is 1.5. Oops. 0. 1.5. And scroll down a little bit, we will see that the z-score is, sorry, the probability is 0.4332. Again, area under the curve is the same thing as the probability of our value being between those two regions. Zoom out a little bit so we can see the other graphs. For part B, it says between negative 1.25 and 2. So somewhere between these values here. So in GeoGebra, we're just going to type in negative 1.25 as my lower bound. And I'm going to double click and press 2 for my upper bound. And we will see that the probability that our x value is between negative 1.25 and 2 will be 0.8716. So we have 2 more examples really quickly. If you remember from the empirical rule says that within 2 standard deviations of the mean, approximately 95% of the data values will be within that region. So let's see how much it actually is. So from negative 2 to positive 2, we'll see that the area here is actually 0.9545, rounding to 4 place values. Right, we have 0.95449, which rounds up to 9545. So in reality, it's 95.45% of the data values are within 2 standard deviations. So the empirical rule is a good approximation, but it's not exact. Let's look at the last example here. The last example says negative 1.96 to positive 1.96. So almost the same thing, but not quite. If we put a negative 1.96 from our lower bound and positive 1.96 for our upper bound, we'll see that the area, or the probability, is almost exactly 95%. 0.950004. So really close to 95% of the graph is within 1.96 standard deviations of the mean. All right, that's enough for this video. I hope you enjoyed it, and thanks for watching.